Hello and welcome to Lecture 2. We're going to be talking about eggs as food objects and eggs as ingredients in food, mostly referring to Chapter 2 of your text. I wanted to open with this picture taken from this website, not so much because it's an incredible picture, but because it shows a few interesting things that we want to start off with. Yolks are produced in the ovaries, and we'll talk more about yolk structures a little bit later, but those yolks are passed along into the oviduct where they're fertilized. Interesting. So what's great about this picture is that it sort of color codes some of the development processes that happen. So in the magnum, the albumin layer is laid down over the course of a few hours, color coded here for this orangish pigment, whereas the yolk is developed again in the ovary here. After we add the yolk, we pass through the isthmus into the uterus where the shell is laid down, and after this, another couple of hours, we're passed into the vagina for delivery through the cloaca. What else is interesting? Usually chickens, we're referring here to chickens, and most birds have only one functioning oviduct. And the other interesting point to make here is that the oviduct is confluent with the intestine, which leads us to a question that we're going to come up against a few different times, which is dangerous bacteria that are present on egg shells. So salmonella, particularly, as we know, in raw eggs is a danger and can cause severe gastric distress and diarrhea. Usually taken care of by careful cleaning and or careful cooking. So this is the reason. Before we talk about eggs as food objects, let's talk a little bit about egg politics. This is a photograph taken down from the New York Times showing a factory egg-laying operation, and these is an operation in which the chickens are sequestered in so-called battery cages. But let's come back to that. So in California, 19 million hens. These are 2007 numbers, by the way. There were 19 million laying hens as opposed to meat hens, producing 5 billion eggs with a net worth of $323 million. This only constitutes a fairly small proportion of U.S. production. These battery cages that these hens are confined in are anywhere from 67 to 80 square inches. This is a very small cage size, and this has led to a lot of anxiety amongst certain subsets of the population, which led to the proposal and passage in California of Proposition 2 in 2008, which stipulates that by 2015, most farm animals, not just chickens, by the way, will be able to lie down, stand up, extend limbs, turn around freely, etc. There's a lot of debate as to the impact that this proposition will have on the economics of egg production, but there's no doubt that it will change the lives of these egg-laying hens. Now, I also wanted to mention this idea of free-range chickens. This is a photograph of a free-range chicken egg-laying facility, egg production facility, and you see that the chickens are allowed access or egress, that is to say, from their cage. This might not be what you imagine when you think of a free-range chicken. It is not pecking along happily along a bright green meadow with cows munching grass in the background. There's no legal standard for what free chickens are with respect to egg production. But you'll see free range, free roaming, or cage free on various egg products. The USDA does have a definition for free range for meat animals. Producers must demonstrate to the agency that the poultry has been allowed access to the outside. So you can see what that means. right? The outside of their cage could mean a variety of things. In any case, whether free-range chicken factories are good or not, the trade association, the United Egg Producers, estimates that there'll be a quarter or 25% increase in costs consumers are paying once Proposition 2 is finally implemented. Interesting stuff. Let's think about eggs, though. Egg gradations. So you probably are familiar with these if you do much shopping. On the left, we'll see that we have jumbo eggs all the way down to peewee sized eggs. 71 grams versus 35 grams. Now, you will probably never see small or peewee in most grocery stores. I think jumbo to medium are the more common. And you'll see that that's almost a third difference in the mass of each of those eggs. And so I encourage you, next time you go to the grocery store, to compare the prices of jumbo and medium eggs and think for yourself about what the most logical choice in terms of those eggs are. And we'll come back to the size issue again in a moment. But let's turn to the gradations. Double A, and B. Again, you're never going to see B in the store. The grade has everything to do with the consistency of the white. And we're going to talk a lot about egg whites today. But it's worth pointing out that double A eggs are going to have a very thick and very firm white. And it also refers to the contents of the yolk. We'll be less concerned with that today. We say these are best for frying and poaching, and that's because the consistency of the white controls the cohesion of that cooked white. So in a poached egg, a double A egg should not diffuse or sort of expand once it hits that water, and instead you should have a nice compact cooked object. Same for frying. The white's not going to spread around in the pan as much. It's going to stick together and form a nice sort of tight mass. And as we get down to A, the whites are considered reasonably firm. You'll see these in stores, obviously, quite frequently, and they're just not they're not as aesthetically pleasing for some products. And grade B eggs are trade eggs. We'll use those, and we won't see those in the store, but we'll use them in other products. Okay, egg structure. Now, the egg is a very complex structure, and I encourage you to go study that some more on your own. I'm only going to point out a few things in this slide. First of all, there's a shell, mostly made, as I've said previously, of calcium carbonate. Interior to that shell are some membranes separating the shell from the albumin or egg white. Albumins is also a term that will refer to specific proteins, but we'll also use it to refer to egg white in general. Egg white's a complicated mixture of protein, as we'll see. The egg white changes over time, and so I say that here new eggs are more acidic, and the albumin tends to adhere to the membrane. So this is a topic that some of you might decide to choose as your own research project: is why are some hard-boiled eggs easy to peel and why are not, and why are others easy? You might, and we'll talk again about this, and your book describes it pretty clearly, that the age of the egg can have a big impact on the peelability of a boiled egg. Another interesting structure that you'll all be familiar with in a raw egg is the chalazae, which are fibrous, thick masses that anchor the yolk to the shell. And then let's look at the yolk. So this picture shows a nice layering occurring within the yolk, and remember that the yolk is created over time in the ovary of the chicken, and a yolk is the yellow part of an egg, Oscar. The layering occurs a lot as the hen's diet varies. So as it's eating, there's an influx of dietary pigments, and you see this layer laid down, and then between meals, you see other layers laid down.
What is the yellow part?
It's the yolk. It's full of fat. So, and below, most of the time, you're not going to see this layering in an egg, but I have shown you one example where you do see some layering occurring in the yolk. This coloration is derived from diet, as I said, mostly from the fat-soluble xanthophylls. These are a class of, or a subset of carotenoid pigments. You're familiar with beta carotene. This is one component of what are actually a diverse set of color pigments in the yolk. It's important to note that those pigments are fat soluble, and we're all familiar with the idea that yolks are full of fat and the whites are full of protein. Okay, thinking like a scientist. So I encourage you at every step to start looking at your food items critically. And so what I've done here in this table on the left is to make some measurements on 10 different eggs from the same set of uh, grade A jumbo eggs from Trader Joe's. And we see that there's quite a range of masses here with an average of 58.2 grams. So I just wanted to take a moment to point out some terms that we might think about. When I say thinking like a scientist, I mean we like to think about questions like, okay, well, here's an egg, and we know what a jumbo egg should be. It should be greater than 70 grams, which these are obviously not. We might say, well, what does an individual egg mean? Chickens lay thousands of eggs over the course of their lifetime, perhaps. Um, Hundreds of thousands of eggs coming out of egg factories every day. How do they vary? Well, we can compute a mean, and you're all are familiar with averages or arithmetic means. This equation isn't so complicated, but I still wanted to show you how we actually compute averages. You're familiar with taking a sum, which is what this sign is, over some n number of different samples, and then dividing that sum by that number in the sample size. That's all an arithmetic mean is. And it should, given that the distribution is very even from in one end to the other, you should see the mean telling you something about what the middle value of the data set is. But there's another number that we can use called the median, which is a middle value, and it reflects the middle value whether the distribution is symmetric around a middle or not. This can be important when your sample is skewed towards a high or low end, or maybe there are multiple distributions. Anyway, the median tells you something specific about that aggregate set of values. A number that scientists also like to use is a standard deviation. That'll just show how much any given data point differs from the mean or the arithmetic average of the set. So plus or minus how much do we, and again, this is it gives us an idea of the accuracy of any given measure as a reflection of the aggregate. We also use 95% confidence interval, and this tells us how confident we are that that number, that mean, reflects an actual value. So we can be 95% confident that our number 8, 59.7, is telling us something real about the overall mass of a jumbo egg from Trader Joe's. But let's look at these numbers. Again, I pointed out that this jumbo egg is by no means jumbo according to the USDA's regulations, 58.2 grams. We'll see that the average and the median are about the same, telling us that our distribution is pretty symmetric around that mean. Standard deviation 1.1, so most of those eggs are going to fall within 1.1 grams of the mean. The 95% confidence level is 0.7 grams. So that tells us that we have a little tighter bounds using that metric of confidence on the average number. So not all eggs weigh the same, and not all eggs weigh what they're supposed to weigh, and we like to measure those things as scientists. We also like to think about the composition of the egg in a more quantitative way. So here we're looking at a photograph that I made before and after shots of a separated egg. And let's just look at some masses first. So I've separated this into 3 components: shell, white, yolk. The mass of this one egg was 59.34 grams. Separated out into shell, 7.2 grams, white, almost 34 grams, yolk 18.18 grams. So the white taking up the lion's share of the wet mass of the egg. But when we dry that out for a couple of days in an oven, what we see is the shell only loses a small fraction of its mass to evaporated water, 17% or so. The white, on the other hand, loses almost 90%, so almost 90% water, going from 34 grams down to about 5 grams, and the yolk only losing 50% of its mass as water. This is interesting. This tells us something. Well, it reflects what we already think we know about eggs. The yolk is mostly fat, or a large percentage of fat, and so it's not going to have a very high water composition, and so it's going to retain most of its mass. Whereas protein, the white is mostly protein, lots of water, and we lose all that water when we dry it out. Okay. Oh, interesting too, to just look at the photographs here. So not much physical changes in a wet and dry eggshell. The yolk, we see that reduced significantly, but not by as much as the white in terms of the physical mass of that object that's lying there. And we see too the volume of the yolk is very much less than the volume of the white, and then we have a very small amount of sort of papery residue left behind, which compares interestingly to this big chunk of oily dried out yolk. Okay. Whites and yolks have very different traits. We've already seen some of that. They have very different jobs or roles that they play. But first, here's another photograph that I snapped of separated yolk and white, and we see that volume difference again, obviously. But here's some pH paper, and again, as an aside, if any of you are thinking about using pH as a variable in any of your kitchen experiments, do not hesitate to come by my office, and we'll find a way to get you the supplies that you might lack, such as litmus paper. Anyway, we see that the pH of the yolk is 5 or 6, low on the acidic side compared to the white, which is more up there at 8 or 9 pH, fairly basic. Anyway, back to these numbers. White, 90% water, 10% protein, less than 1% fat and carbohydrate, some vitamins, although limited quantities, and there will be trace amounts of other vitamins. I'm only showing you here the vitamins that are present in any appreciable quantity. The role of the white is the protection of the embryo, and I'll mention that again in a moment. But first, turning to the yolk. So 50% water, as we've seen, 25% fat, 5% carbohydrate. Nutrients, providing a lot of nutrients for the embryo. As we'll see, vitamins A, B1, B5, B9, B12, as well as some important lipids, phosphatidylcholine, and cholesterol. What else to say about this? Oh, well, it's interesting to point out that many of the proteins in the embryo, again, are there to protect the embryo, and so they'll provide. We'll go into the in a later lecture. We'll talk more about the nature of vitamins and their role in nutrition. Suffice it to say that these vitamins are fat-soluble vitamins. That is why we find them in the yolk. Phosphatidylcholine is a very important surfactant molecule. It's a glycerophospholipid, as I said before, and we'll talk about its role as we move along, or as the glycerophospholipids as emulsifiers in cooking with eggs. As well, cholesterol is present, 200 or 300 milligrams in a single yolk of an egg, which is quite a lot of cholesterol, and we'll talk more about that in a few slides.